Not gonna lie,
Then
I
I'm
just
going to
started
have
this
to do
early because I
negative
forgot my
3 times
class.
negative 2y, and that's going to give me positive 6y. And then I have to do negative 3 times negative 6, which is going to give me positive 18. And the bottom one we're not adjusting, so I'm just going to copy it. I'm just going to copy 6x minus 6y equals negative 18. Now I can add these together, and I'm happy with her selection because these are gonna wipe out, right? I got negative 6x and positive 6x. They wipe out. That's good. I want to cancel stuff out. So that works. And then something strange happens. 6y and negative 6y also cancel out. So I get those to go away too. So since everything on the left-hand side is removed, that's just 0. On the right-hand side, look at this. I have 18 and negative 18. Those cancel out as well. That makes 0 as well. So now I end up with a 0 on the left and a 0 on the right. And this is true, right? 0 does equal 0. So my constant on my left side and the constant I get on the right side, they're the same. Okay, these are the same. I end up with the same value on each side of the equation, which is true. 0 does equal 0. So this is unlike the last example. Okay, I want to show you everything together. So in the first example, we worked it out, we solved it. This was yesterday or even before. Let me go back one more. The very first example we worked out, we solved and we got actual values for X, Y, and Z. We found values. We found values that make it work out. That's a single solution. You have values for X, Y, and Z. There's only one value for X, one value for Y, and one value for Z. That's a single solution. Okay, that's one possibility. Um, Yesterday we tried to work it out and we got a constant equaling a different constant. And when that happens, right, you can't do any more work. And when this happens, since these are different, we said that the constant on one side is not the same as the constant on the other because 0 and negative 7 are different values. There's no solution when that happens. But when we solve and we get constants on both sides and those constants are the same, this is something different. This is the case where there are infinitely many solutions. So this problem would have infinitely many solutions. Okay. And the difference here is that you end up with two constants, but they're the same constant. Okay. So that's why you have infinitely many solutions. So there are three possibilities. You can do the problem and it works out, and you find X, Y, and Z, and then there's one solution. The answer you get is your solution. You could do the problem and you get one constant and a different constant on the other side. That means there's no solution. And the third possibility, you can work it out and get the constant on the left and the constant on the right are the same constant, right? In this case, they're both 0. And that means there are infinitely many solutions. Now, your book actually solves for uh, each variable in terms of the other variable. So we could do that. I didn't do that in my other class today. So I may show you that tomorrow. All right. I can show you how to write infinitely many solutions. There's a couple of ways you can write that, but I'm going to save that for tomorrow because I didn't show it there yet either. So, and plus, my focus today is really on real world problems. So I really want to show you today how to solve a real life problem. In other words, I want to show you a word problem. And the word problem is a little bit time consuming because we are forced to convert a word problem into a mathematical model. And that's not that easy. So I want to make sure I have enough time to do that. So I'm going to jump to that now. And then tomorrow I'll wrap up. I'll do more examples, just actually doing the algebra in these questions. I know it takes time to get good at these. This is not that easy. There's a lot of things going on in these problems. So let me get to the word problem, which is really like the main event for today. This is really it. This question here. So I'm going to show you this, and then I'll show you maybe. In my other class, I did this in one more example, and that was all I did because this problem is long. So let's get started. I don't want to not get this one done. So an amphitheater is just like it's a theater where they have music. It's like a really big, giant thing. Um, so this theater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. Okay. So section A is expensive, kind of, and then section B is a little cheaper, and then the lawn seats are the cheapest at $30 each. Um, there are three times as many seats in section B as section A. That's probably going to be important. The revenue from selling all 23,000 seats is $870,000. If you don't know what this word means, the revenue is the money that we take in when we sell something. So, for example, if you were selling backpacks for $10 each, right? If you sell five backpacks for $10 each, your revenue is $50, right? Your five backpacks you sold times $10 each is $50 of the money you take in. Okay, so the revenue is the money you receive from selling something. So the revenue from selling all the seats, and there's 23,000 of them, is this amount of money, so 870 grand. How many seats are in each section of the amphitheater? So, okay, well, let's go back now and try to write down some equations based off of the words. So honestly, these questions sometimes they take two, three, even four passes of reading through it to get what you need, and that's fine. So if you have my College Now class, then you're going to be more used to doing this, and if you don't, then I haven't done much of this in this class. Okay, where we take a word problem and then we write out equations. In the other course, it happens like in every example. Um, so here, okay, let's see what we got. So the amphitheater charges $75 for each seat in section A. So this is money. So you know what? I'm going to write an equation that deals with money first. So for every seat in section A I sell, I get $75, it looks like. Okay. So that means I can say 75A. In other words, for every time we sell a seat in section A, we're going to bring in 75 bucks. We're also going to bring in $55 for B. So if I sell a seat in section B, that's $55 for every seat in section B. So 55B. And I also take in money when I sell lawn seats. I'm going to call the lawn seats C. All right. It doesn't make a difference. So 30C. Every lawn seat I sell, I bring in $30. Okay. That's the money I bring in. 75 for every seat in A, 55 for every seat in B, and $30 for every seat in C. Um, there were three times as many seats in B as A. Well, that's important, but I'm not ready yet. The revenue from selling all 20 to 23,000 seats. Well, a common mistake is students write down that this equals 23,000, and that's wrong. 23,000 is not the money. 23,000 is a number of seats, okay? This equation that I've made deals with money. It's $75 for every seat in A, 55 bucks for everyone in B, and $30 for everyone in C. This is all about money. So if you sell all these seats at these prices, the amount of money we're going to get is this amount here, 870,000. Okay? So this is a money equation. So if these are in terms of dollars, then the equals better be in terms of dollars as well. I hope that's okay, right? You have to be consistent. There's a money equation, so it should equal some amount of money. All right. So I have my money equation written down. That's all I can do here. This is the amount of revenue we take in. 75 for A, 55 for B, 30 for C, and the total revenue, if you add the money you get from selling all the seats at these prices, is this amount of money. Okay. So that's the first thing. The second thing is that second sentence, which seems a little weird. That second sentence here, there are three times as many seats in section B as section A. There are three times as many seats in section B as in section A. So, question, there are three times as many seats in section B as section A. Which section has more seats?
B.
Yeah, B has more seats. B has way more. B has three times the amount of seats. Okay, so B is three times the amount of seats in section A. All right. So B is equal to three times whatever A is. For example, if A only had one seat, right? If A had one seat, then B would have three times one, which is three seats. a 3-to-1 ratio. If A has 50 seats, then B, this side would equal 3 times this would be 150. Again, 150 to 50 is a 3-to-1 ratio, right? It's supposed to be 3 times as many. If A had, let's say, 100 seats, right? 3 times this 100 here would be 300. So again, we see that B is a 3-to-1 ratio. So this works. So for every seat in A, B has 3 times the amount of A. So we can say the second equation can be B equals 3A. Okay, that comes from this sentence here. There are 3 times as many seats in section B as section A. So that means B is 3 times the number of seats in A. B is much larger. Okay. Um, Finally, the revenue for selling all 23,000 seats, sorry. The revenue from selling all 23,000 seats. So we know that in the whole theater, there are a total of 23,000 seats altogether, meaning that the seats in section A plus the seats in section B plus the seats in section C have to total up to 23,000, because altogether there are 23,000 seats inside this theater. All right. So however many there are in A plus however many there are in B plus however many seats there are in section C, that's got to equal a grand total of 23,000 seats. All right. Altogether, that's how many seats we're going to have. So those are my 3 equations. I have a money equation. I have the fact that the number of seats in section B is 3 times the number of seats in section A. And I also know the total number of seats inside this theater is 23,000 seats, which means all the seats in A plus all the seats in B plus all the seats inside C have to equal 23,000. That's what I know so far. Okay, any questions about anything so far? Anything?
No.
Okay. All right. So I'm sorry if this question is the way I'm solving this one's going to feel a little uncomfortable, because in most of the questions we've done, it's been the elimination method that we've used. But this question doesn't really, it's going to be very hard to use the elimination method on this example. This one is much easier to do substitution. And how do you know to do substitution? Whenever you have pieces that are missing, like equation 2 doesn't even have C in it. So whenever there are parts missing, it's normally going to be a substitution approach is going to be easier. Can you still do elimination? The answer is yes, you can, but it's actually going to be harder to do elimination in this particular problem. So I'm going to do substitution because it's just easier in this example. To do elimination, I'd have to force it. I don't want to force an elimination method, for no reason. So what I can do is this statement right here, statement 2, is really helpful. So I have statement 1, statement 2, and statement 3. The second statement is super helpful because what we know is that if B is 3A, B is 3A, that means I can replace this B with 3A. I can put 3A in there. All right. So what I'm going to do is I'm going to rewrite this equation. I'm going to rewrite equation 1, replacing B with its value, 3A. And that allows me to say 75A plus 55 times, I'm replacing B with 3 over A, because B and 3 over A are the same, they're equal. It says it right here, plus 30C equals 870,000. So this is nice, right? This makes life a lot easier. So now I can say 75A plus, okay, 55 times 3. 55 times 3, what is that? 165. 165A plus 30C equals 870,000. I didn't do anything except I did one thing. I simply multiplied 55 times 3A. That's all I did. I multiplied these two things and I got 165A. That's all I did. And why did I do that? Because now everything is in terms of two variables. It's A and C only. And I can combine 75A and 165A. If you add 75A and 165A, that's 140A if you put it together. 140A plus 30C equals 870,000. Okay, so that's everything there. I can't do any more with this. I got this down to two variables, which is great. Okay, it's really helpful. So I substituted 2 into equation 1, and now I have equation 1 down to two variables.
Mr. MPZ,
Yes, yes.
75 plus 165 equal, I think, 240.
240. Thank you. All right, how do I write 140? Thank you. 240. Okay, thank you. All right. So yes, okay. Everything looks good now. So equation 1 now is down to two variables. Okay, it's down to two variables, which is nice. I'm also going to rewrite equation 3. Okay, because B is 3A and I replace that here, I can also replace the B in statement 3 with 3A as well. That's going to also be helpful. So I can replace that too. In other words, I can rewrite equation 3 as A plus, I'm going to put 3A in there, right? Because B is 3A. So I can put 3A in there. So A plus 3A plus C equals 23,000. And then I can combine these terms. 3A and 1A is 4A, right? So 4A plus C is equal to 23,000. And this is really good news too, because look, I have both this equation, equation 1, and equation 3 are now in terms of A and C only. And I used the second one to go into both of them. So really I used 1 and 2 here. I just didn't 2 got substituted in, and I used 2 and 3 here. Okay. In this statement, I substituted 2 into equation 1, and over here I substituted 2 into equation 3. So I am, in a sense, still using two equations for each, and they're different, right? I used 1 and 2 and 2 and 3. 2 was easy to do substitution with. That's why I did it this way. It's just easy. Okay, now it's a system of equations which we know how to solve. It's a system of equations. It's two equations with two variables. This is the easier type of stuff that we do in the past in like algebra 1. So I have 240A plus 30C equals 870,000. And then I have 4A plus C equals 23,000. So you guys get to select. You could work with variable A or variable C and eliminate one of them, or using the technique that we used the last couple of sessions. So you have to pick a variable that you want to cancel out. Now I will grant you, working with one of the variables, the numbers are a little easier than the other, but that's your choice. It doesn't make a difference. It'll still work. So somebody want to pick a variable to eliminate?
C.
Yeah, I think C is the easier choice. C is the easier choice for sure. So thank you. I'll take C. So C, if we're using C, the numbers for C are 30 and 1. So this is not okay. So I have 30 and I have 1, right? Now I need, if I add 30, admit there's an invisible 1 here. If I add 30 and 1 together, I'm not going to get 0. I'm going to get 31. So I'm not okay right now. How do I make it so that these numbers will add to 0? What do I have to do to make this work out?
Don't you have to like multiply?
Yes. Which one do you want me to multiply?
The one on the bottom, the 4a plus.
Yes, I agree with that. That's this one, right? That's the one with the 1 in it. So which should I multiply the 1 by? I agree with everything you're telling me.
Negative 30.
Yes, I'm going to have to multiply by negative 30. Okay, if I multiply by negative 30, I'm going to end up with 30 and negative 30, and those are going to cancel out. So yes, I had to multiply the bottom one, okay, the one with 1c in it, here's the one with 1c, by negative 30. All right, so let me just copy the top because I'm not doing anything to the top one. The top one is just 240a plus 30c equals 870,000. And then the bottom one, well, negative 30 times 4a, negative 120a. And then I have to do negative 30 times 1c, negative 30c, which is what I wanted. And then finally, negative 30 times 23,000. Okay, let's maybe use a calculator for this. 23,000 times negative 30, 23,000 times negative 30. Oops. 23,000 times 30, and then make it negative. So I have 690,000 negative. Can somebody verify that? Okay, so I have 690,000 as a negative because a negative 30 times a negative times a positive is a negative. So this looks like it's good. So now we should be able to put these together, right? And we're going to get what we want. The 30c and negative 30c are going to cancel out. So that was our goal. We achieved our goal. 240a minus 120a. That's 120a. And 870,000 minus what? 690,000. That's 180,000. And we have one more step to getting A all by itself, and that's dividing 120 on each side, which I'll do next to get A by itself. So I divide by 120. Okay, that cancels out. I divide this side by 120. And if I divide 180,000 by 120, I believe A is 1,500. And let's just check that. And I have 1,500. So there we go. So A is 1,500. So that's the value of A. All right, we got A. Unfortunately, no, it's not done because that's just how many seats there are. A, the value of A is the number of seats in section A, right? So I know there are 1,500 seats in section A. Let me just erase this work. I'll put my answer over there. So when I answer this question should look like A, comma B, comma C, right? So I know my A value is 1,500. I got to find my B value and then my C value. Well, once I know A though, once you find one of the variables, it's pretty easy. To find B, we can just go back up and statement 2 is really easy to find B. So B is just 3A. So if we want to find B, we know that B is equal to 3A, and we know that A is 1,500. So B is equal to 3. I can just replace A with 1,500. And that means that B is equal to 4,500. Okay, I just did 3 times 1,500. We know it's a 3-to-1 relationship. So whatever A has, B is 3 times the size of A. So 1,500, 3 times the size of that is 4,500. And I have one more thing that I need. I found my B value, which is great, but I also need to find my C value. So let's find the C value. The C value, you can't use statement 2 to find C because, well, C is not there. So you could either use statement A, the first statement, statement 1, or statement 3. If you don't mind, I'm going to use 3 only because it's easier. And yes, if you want to use statement 1, it'll absolutely work. But statement 3 is just less math. So I'm just going to pick statement 3 to work with. A plus B plus C is 23,000. Well, I know A is 1,500, so I can replace A with 1,500. And I know B is 4,500. I don't know what C is, but I know the total has to be 23,000 seats. So now it's pretty easy. If I add these together, that's 6,000. And then to get C all by itself, I could subtract 6,000 from each side. Those cancel. Subtract 6,000. And then C has to equal 23,000 minus 6,000. I believe that's 17,000. So that is the value of the number of lawn seats. There are 17,000 lawn seats. So let me just go back up and make sure I write this in there that I have 17,000 lawn seats. So that goes here. That's C, 17,000. So this would be my answer. My answer is 1,500, comma 4,500, comma 17,000 because there are 1,500 seats in section A, 4,500 seats in section B, and there are 17,000 seats that are lawn seats. And that would be everything. Those are all we found all the values. I don't want to say it's hard, but it's a lot going on. You have to convert the word problem into this. To me, this part's the hard part to me is this. Going from the words into these 3 equations to me is not easy. That's a skill. It takes time and practice to be able to start to do that to do that well. So you got to give yourself some time to get there, but you'll get there. That's basically it for this one. I think solving this one wasn't that bad. It was substitution, so it wasn't anything crazy. I just basically put 3A into B and put 3A into B here. And when I did that, I get a system of equations where we have 2 variables, which at this point, you solve those questions in algebra A a lot, so you should be a little getting comfortable with those. And that's basically it. I don't really have much else to say about this one. I'm going to do one more example, which is like we did the other day, where you use elimination, and then we'll end on that. But before I go to that, are there any questions on this at all so far? Anything?
No.
Nothing? Okay. So with that, let me just go to the last example then, and then that'll be at. There's a homework I think that's on this that I think is due tomorrow night. So because we're gonna finish tomorrow will be the last lesson of this stuff, and then I'm moving on to something else. All right, the review actually. So you'll have an assessment, I believe. I think next week sometime, probably Tuesday or probably Wednesday. So midweek you'll have a first assessment. We'll talk about that when we get there. All right. Anyway, let me do the last example because the time is running out. Time goes quick in here. All right. So to keep in the same place, my other class, I did example 2 with them. So because we did example 1 previously. I see 1's already worked out. We did it already. So 1's done. Okay, let's do example 2. I have to just copy it. So x plus y minus z is -1. So x plus y minus z is -1. And statement 2, 4x plus 4y minus 4z. 4x plus 4y minus 4z. I believe that's -2. And it is. And 3x, 2y, z is 0. 3x plus 2y plus. Let me make sure I copy that right. 2x plus 3y plus z is 0. Okay, I did it wrong. 3x plus 2y plus z is 0. Okay, let me fix that. Okay, so 3x plus 2y plus z is 0. All right, that looks like it's right. Let me just divide this up. Okay, so now we're looking at question 2, okay? And this is one of those questions where it's probably going to be best to just use the elimination strategy, which we learned previously. So let me label these equations as equation 1, equation 2, equation 3, and you can pick 2 out of the 3 choices, and we'll work it out from there. Just look at them carefully. Some choices result in less work than others. Some choices, stuff wipes out right away, and I think it's best to pick that. But if you don't pick that, that's fine, right? You could still solve it. It doesn't matter. So let me give people a chance to. Somebody want to give me equations that I should choose?
1 and 3.
Yeah, 1 and 3 is a great choice. My other class picked 1 and 3 as well. That's what I would choose. So if we choose 1, 1 is x plus y minus z equals -1. And then 3 is 3x plus 2y plus z equals 0. And this is a good choice because if you look at it carefully, you can see that negative z and positive z are going to cancel out when you add them together. So you could skip doing multiplication in this one. You already have things that cancel out. You can just go straight to putting the equations together. And that's nice because it just makes the work a little easier. So if you add these the way they are, 3x and 1x are 4x. And then 1y plus 2y, that's just 3y. And his choice is good because -1z and +1z eliminate each other. So z is gone. And -1 plus 0 is -1. All right, so that was a nice choice. We got rid of z, so we have 4x plus 3y equals -1. We're down to 2 variables, so mission accomplished so far. Now we have to go again. We need 2 equations, and we can't pick 1 and 3 because we chose that already. If we choose 1 and 3, we're wasting our time because we did it already. So somebody want to give me something different we can pick? A different combination?
One and two.
And 3.
Okay, so I got 1. Yeah, it could go either way. So you could do 1 and 2 or 2 and 3. It doesn't really matter. I heard them both at the same time. I think it was. So if we're doing 2 and 3, okay, whatever. Either way will work. 4x. This one is not as important because this selection, you're gonna have to do work to solve it anyway. So there's no way. There's no way to avoid multiplication. Okay, I just wrote down. I think I heard 3, but it could be either one. If you want to do 1 and 2 again, that'll work too. Doesn't matter. Whatever ones you pick, whether you pick 1 and 2 or 2 and 3, whatever you pick, you're gonna have to eliminate variable z. You don't have a choice there. You must get rid of z. Why must you get rid of z? Because you got rid of z in the first one. Okay, over here you killed off z, so you have to kill off z again. Otherwise, it's not going to work out. So I have to eliminate z again. So let me look at my z values. My z values are -4 and +1. So these are not going to cancel out. These are not going to cancel out the way they are. You're going to have to do something to one of them to make them cancel out. Anybody have any ideas of what we can do?
Multiply the third equation by -4.
Yes, multiply the one with 1 in it. Okay, equation 3 by yes.
Shoot, wrong number.
So was that you were right. Oh, 4. Yes, 4.
By
Yes.
4, yeah.
Yeah, by 4. I agree. Okay, you're going to multiply this thing by 4 so that you could have -4 and +4, which are then going to cancel out. Okay, you need them. You need one to be negative and one to be positive. So this one up here is already negative. So this one's positive. We're good. So we multiply this by 4, and it's going to eliminate it. So I have to multiply all of equation 3 by 4. All right. So the good news is I leave statement 2 alone. So statement 2 is simply 4x plus 4y minus 4z equals -2. And this one, let's be careful now. 4 times 3x is going to give me 12x. And then 4 times 2y is going to give me 8y. And then 4 times z, well, that's what I wanted. I want 4z positive so I can cancel. So mission accomplished there. And then last but not least, 4 times 0, well, that's easy. 4 times 0 is still 0. Okay, so now I can combine these and just add them together, right? I can add these together now. Let's see what happens when we add them together. That's 16x, right? 4x and 12x is 16x. Put these together, 8y and 4y is 12y. Okay, we're good there. We mission accomplished here. These cancel out because one's -4z, one's +4z. And -2 plus 0 is -2. So here's one equation. My other equation's over here. Let me put these next to each other. I have 4x plus 3y equals -1. And I have 16x plus 12y equals -2. Okay, so if I add these together, unfortunately, nothing is going to eliminate. So you're going to have to pick a variable here, either x or y, and then eliminate that variable. So somebody want to select one?
Multiply the top equation by 4.
Okay, yes, but one thing, multiply the top
Oh,
equation.
negative.
That's correct, okay? Multiply the top equation by -4. This is going to eliminate the x's for sure. Oh, and it also eliminates the y's too. Okay, so let's say we decide to work with the x's. The x's are 4 and 16. By multiplying this 4 by a -4, you'd get -16 and 16, which eliminates. So that's why this choice is solid. So I have to multiply this all the way through. Let me do that now. -4 times 4x is going to be -16x. So that's going to eliminate. -4 times 3y, that's -12y. And -4 times -1 is +4. And now I'm just going to copy down my 16x, my 12y, and my -2. And now I'm ready to add these together. So when I add these together, I achieve my goal. The x's are going to cancel out. But look at this. In addition to the x's canceling out, the y's also are canceling out, -12y and +12y. So there's nothing left on the left-hand side of this equation. Everything's gone. It's 0. On the right, 4 minus 2 is 2. So I have 0 equals to 2. I have a constant equaling a different constant. What does that mean? What's the answer to this question, since I can't go any further?
No
There's no
solution.
solution.
Yeah, there's no solution. There's no solution because this is not true. The constant on the left and the constant on the right are unequal constants, right? C1 and C2, they're different. They're unequal constants. So therefore, this one has there is no solution. No solution. Okay, so that would be it for this. There's just no solution for this one. That's basically everything that I wanted to do today. We got to do a word problem and we got to do one with a elimination technique. And listen, you can use either technique, elimination or substitution. I would say which one you use depends on what how the material is presented. Okay, there's no right or wrong. It's about what's going to be easier for you. So for me, in this example, and elimination was just easier. In the other example, substitution was just easier. And that's basically it for today. If there aren't any questions, if you have questions, I'll take them. If not, I think I'm going to stop here. The next review session, and some people came to yesterday's. The next review session will be Friday. I'll probably start that around 3.